Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is NURFATINAH binti Muhammad MUNIR, and right now I am going to explain on how to do the calculation for question number 1. There is two part of question number 1, and this is the first question. So we need to use integration by parts to evaluate and get the answer for these questions. The first question is the integrations of x inverse tan x squared dx. Okay, the first function is x and the second function is inverse tan x squared. First of all, we need to use Layat rule to do this integration by part technique. We use this rule to determine which function should be u and dv. As you can see here, here is some example of Layat rule. The example given is LIATE, and this is all the example I can get to put in this Layat rule. Okay, according to the Layat rule on the previous slide, so if we can see here, x will be a and inverse tan x squared will be I. So I come first before a. So tan x, inverse tan x squared will be u and x will be dv. So according to inverse derivative formula, first of all, we need to find du over dx. According to derivative formula, du over dx of inverse tan x squared is 2x over 1 plus x power of 4. So the du is, we should bring the dx here, and it will be 2x over 1 plus x power of 4 dx. So the dv is x dx. If we want to get the v, we have to integrate the x dx. So v is equal to x squared of 2 after we integrate the x dx. So as you can see here, we already get the information of u, du, dv, and v. The next step is we have to use the formula of integration by technique, integration by part, which is the formula is integrations of u dv equal to uv minus integrations of v du. As you can see here, the integrations of u dv is the question itself, which is integrations of x inverse tan x squared dx equals to u, which is the u we get here is inverse tan x squared, and the v here is x squared over 2. Minus with integrations of v, the v is x squared over 2, and the du is equal to 2x over 1 plus x squared dx, which I wrote here. So what you need to do is we need to solve this problem here, which is we need to simplify here. So the first thing first is we have to solve this here, and we will get inverse tan x squared multiplied with x squared over 2, and here this equation, after we solve it, we will get integrations of x cubed over 1 plus x power of 4 dx. As you can see here, this equation is not complete yet because, or it is not solved yet because this equation still has integration symbol in it. So we have to solve this problem first. So what we need to do here is we have to complete this. We have to solve this equation by using the use substitution method. So the integrations of x cubed over 1 plus x power of 4 dx, we have to use u substitution and let u become the become 1 plus x power of 4, and du over dx for this is 4x cubed, and the dx is du over 4x cubed. Next one, we have to substitute the x to become u in this equation, which we will get integrations of x cubed over u, because we already changed it to u, multiply du over 4x cubed. And after we simplify this, we will get integrations 1 over u du over 4, and we will get 1 over 4 integrations of 1 over u du equals to, after we integrate the 1 over u du, we will get ln u. So if we write it again, we will get 1 over 4 ln u. So the u here is the same as u is equal to 1 plus x power of 4. So we put back the x value, and it will become 1 over 4 ln 1 plus x power of 4. So after we settle this, we get the new equation here. So we have to put it back in the integration by part formula, which we get before this, which is integrations of x inverse tan x squared dx uh, equal to here what we get before, inverse tan x squared over 2 minus the new equation that we get, which is 1 over 4 ln 1 plus x power of 4. And this is the final answer that I get for this question, which is inverse tan x power of 2 x squared multiply x squared over 2 minus 1 over 4 ln 1 plus x power of 4 plus c. Okay, next we will move to the next question, question B, which is integrations of 3x squared minus x plus 2ex dx. So first of all, what we need to do is we have to identify how many function here. There is two function here. The first function is 3x squared minus x plus 2, and the second function is ex. So what we need to do is we have to use the Layard rule to identify which function is u and which function is dv. According to Layard rule, 3x squared minus x plus 2 will become a, and ex will become e. Here, according to here, you can see here the example of Layard rule. So, after we determine the u and dv, we have to let u equals to 3x squared minus x plus 2, and we have to find the du over dx here. So the du over dx for this equation here is 6x minus 1, because this power of x should be multiplied with 3, which we will get 6 here, and 2 have to minus with 1, and we will get x. X here, the power of 1 have to be minus with 1, and we will get 1 here. So we have to find the du. The du is equal to 6x minus 1 dx, because the dx here we multiply with 6x minus 1, and we will get it. We will get this. So the dv for this problem is ex dx. So how to get the v is we have to integrate the ex. According to the integration formula, if we integrate ex, we will also have ex. Okay, after we find all the info of u, dv, du, and v, we have to use the integration by part formula, which is integrations of u dv equal uv minus integrations of v du. So integrations of u dv is equal to 3x squared minus x plus 2 ex dx equal to uv. The u is 3x squared minus x plus 2, and the v is ex, minus integrations of v. The v is ex, and the du is 6x minus 1 dx. So after we we multiply with here ex here, and we will get 3x squared ex, and x here we multiply with ex, which we will get x ex, plus 2 we multiply ex, we will get 2ex minus integrations of ex 6x minus 1 dx. So as you can see here, it is not complete yet, it is not solved yet, because it still has integration in this equation. So what we need to do is, so what I do to solve this integration is, I use integration by part again, and I use Layard rule to determine which is the dv and which is u. So after I use Layard rule, I get that the dv is ex and the u is 6x minus 1. So let u equal 6x minus 1, and we have to find the du over dx here. It is equal to 6, because x power of 1 minus 1 equal to 6 only, and the du is 6 dx equal to 6 dx. The dv here, what we get here is the dv is ex. So what we have to do to get the v is we have to integrate ex. which we will get, also we will get EX, because the integration according to the formula of integration, if we integrate EX, we still get EX. So we use the formula, integrations of UdV or equals to UV minus integrations of VDU. So we will get integrations of EX 6x minus 1 dx equal to U, which is 6x minus 1, and the V is EX, minus integrations of V, which is EX, and the du is equal to 6 dx. So after we solve this, we will get this will multiply with this, and we will get 6x EX minus EX, and we will solve this, which we will get, we have to integrate this, and we will get 6EX plus C. So what we have to do here is we use this new equation to put it in the equation before that we get, which is not complete. We have to change this become this. So what we need to do is the integrations of 3x squared minus x plus 2 EX dx is equal to 3x, which is here is the equation, we need to write it back, 3x squared EX minus x EX plus 2EX, minus which this equation we have to write it here, 6x EX plus EX plus 6EX plus C. So right now what we have to do is we have to rearrange this equation here so that it become neat and we can understand it better. So first we will have to take this and put here 3x squared EX minus which x EX minus x 6x EX plus with 2EX plus with EX plus 6EX plus C. So 3 here will never change, so it will become 3x squared EX, and here the negative x EX will minus with 6EX x, and we will get 7x EX, and here 2EX plus EX plus 6EX we will get, after we total this up, we will get 6EX and plus C. This is the final answer for this question B.
So for question 2a, we're going to show that x squared plus 4x plus 7 is equals to x2 squared plus 3. So we're going to prove this question by using completing the square. And for completing the square, we're just only going to use this formula right here. So from the quadratic formula, dA is equals to 1, B is equal to 4, and C is equals to 7. So we're just going to put this information right here into this formula. So A is 1 here, B is 4 over 2, 1 power of 2 minus 4 over 2 plus 7 over 1. So we're going to solve this, and it's going to be x plus 2 squared minus 2 squared plus 7, and we solve this again. So 2 squared is equals to negative 4, and this one right here is no changes. So we're just going to solve this, which is negative 4 plus 7 is equals to 3. So we got the x plus 2 squared plus 3. So we can prove that x squared plus 4x plus 7 is equals to x plus 2 squared plus 3. So for the next step, we're going to integrate this quadratic equation, which is 2x over 2 x power of 2 plus 4x plus 7 dx. And we already proved here by the completing the squares, so we already got the 2 over x plus 2 squared plus 3 dx. So for the next step, we're going to use substitution to settle this integration, and the next step is we're going to find the u. So our u is x plus 2, and the next step is to find the du over dx, which is 1. So we already have this 1, so we need to find du. So our du is equal to dx. And the next step is we're going to substitute u into this formula right here, which is 1 over u squared plus 3 du. 2, we already separated outside the integration, and we have the limit 3 and 1. Okay, so for the next step is we're going to finish all this by the formula 1 a plus 2 plus u power of a power of 2 plus u power of 2 du is equal to 1 over a tangent inverse b over a plus c. So our a square is 3, so our a is set 3, our u square is u, so our u is u. So we're going to just put in the a and u inside formula right here, inside this formula. So which we got 1 over 3 square, 1 over set 3, tangent inverse u over set 3. And for the fifth step, we're just going to find the value from the limit that we already got in the first question, in the beginning of the question, which is tangent 1 over 3 tangent inverse u over set 3 over set 3. This is from the formula, and then we're just going to put in the 3 and 1 from the limit, and we just calculate all this information, which we got 0.646 minus 0.3023, and then 2 from this, which is going to times 2 times 0.3023, which we get 0.6046 as the final answer.
Assalamualaikum warahmatullahi wabarakatuh. My name is FARHANNY NELLYSHA, and for this assessment, I will be explaining the solution for the question 3. So let's look at our question here, question 3. This is our question. Use partial fraction to find the values of A, B, and C. This is a quadratic factor. Why I say that? Because if you see over here, equation over here, this is actually a x power of 2 plus bx plus c. So it is a quadratic factors, and this one here is a proper function. Why I say that? Because if you can see here, the degree of fx is 2 and the degree of gx is 3, which means degree of x is actually less than the degree gx, so it is a proper function. So the first step to find the values of a, b, and c is we need to standardize the denominator on the right hand side here. So how to standardize this one? You can cross multiply, where a multiplied by must be multiplied by x power of 2 plus 1, and bx plus c must be multiplied by 4x plus 1. This is how we get after we cross multiply. A bracket x power of 2 plus 1 plus bx plus c multiplied by 4x plus 1, and the denominator is already the same as the left hand side. Now the second step is how to determine the a, b, and c. Since the our denominator on the left hand side and right hand side is already the same, so we can just take the equation, the upper one here, left hand side cx power of 2 minus 3x plus 1 equal to, on the right hand side here, just take the upper one, a x power of 2 plus 1, bx plus c 4x plus 1. So that is our first equation here. So how to determine the A, B, and C by using this x factor value. So we take for x plus 1 equal to 0. So our x value is -1/4. That is the second step. So the third step is substitute the value of x from the factor. So this is our equation from the start to here, and we just need to substitute the value of x inside this equation. So 6 -1/4 power of 2 minus 3 -1/4 plus 1 and equal to A -1/4 power of 2 plus 1 plus B -1/4 plus C and 4 -1/4 plus 1. So after do some calculation, this one actually we get a value 0. So we just focus over here. A we get 17/16, and on the left hand side here we get 17/18, and after do some calculation, the value of A is actually equal to 2. So we already get the value of A, which is 2. So the first step is to compare the coefficient. This is the original equation here, the equation from the step 2. So 6x power 2 minus 3x plus 1 equal to 2. This is from the value of A. So x power 2 plus 1 plus bx plus c 4x plus 1. So let's expand the equation here. 2 multiplied by x power of 2. 2 multiplied by plus 1. So we got 2x power 2 plus 2. So bx multiplied by the 4x, we got 4 bx power 2. Bx multiplied by the plus 1, so we got the bx. X multiplied by the 4x, so we got 4xc and 4xc. So c multiplied by 1, so yes, we got the c. So this is our new equation here. So let's factorize it. So we got 2 plus 4b in bracket x power of 2 plus in bracket b plus 4c x plus c plus 2. So this we need to factorize this equation here. So let's compare it. So this is x power 2. This is x power 2. So we take the 6, we compare it to this one in bracket here, 2 plus 4b. So the b, we got the value, and the value is b equal to 1. So we already got the a and b. The last one is for the c. The c1 is here, b plus 4c. We take from here -3, we compare it. -3 equal to b plus 4c, and c is equal to -1. So we already got all the value of a, b, and c, where a is actually 2, b is 1, so c is -1. So that is the first step. We need to compare the coefficient. So we already settled with the question A. Let's move to the question B. Our question B is hence integration 6x power 2 minus 3x plus 1 over 4x plus 1 x power 2 plus 1 dx. This is actually the continuation question. So how to solve this? So just write back the equation, integration here, and equal to the, we take the equation from the question A, the a over 4x plus 1 plus bx plus c over x2 plus 1. Since we already got the value of a, b, and c, so just put the value into the equation. So let's integrate it. Integration 2 over 4x plus 1. 2 is from the value of this a, and plus integration x minus 1 x power of 2 plus 1 dx. Why just x? Because the value of b is 1 here multiplied by x, so it's just the x. So we took out the number here 2, and integration 1 over 4x plus 1, and we took out this one, negative 1, integration x over x power of 2 plus 1 dx. So let's solve the first part here. So we can simplify this one. So this is 2 and this is 1. So after we integrate it, we got 1 over 2 ln 4x plus 1. So for this one over here, we need to use the U substitution method. So here, integration x over x power of 2 plus 1 dx. So which is our U? Our U is actually x power of 2 plus 1. So du over dx, we got 2x, and we need to, for our dx is actually equal to du over 2x. So let's integrate it. Integration x over, we choose this as our u, so let's use u multiply by dx. We have the value of dx here, du over 2x. So you can cross it. So we have 1 over 2, sorry, we can cross only the x here. So we have the value 1 over 2 integration 1 over u du. So after integrate it, we got 1 over 2 ln u. So let's substitute the value u. 1 over 2 ln x power of 2 plus 1. So the integration for this part here is negative, because this is negative. Negative 1 over 2 ln x power of 2 plus 1, and dx is actually the c. So our final answer is over here, 1 over 2 ln 4x plus 1 minus 1 over 2 ln x power of 2 plus 1 and plus c. So that's how we solve for the question 3. Thank you. I think that's all from me.
Assalamualaikum and hi. My name is NURFATINAH HUSNAMILLAH binti Nazri, and my matric number is 2022996739. So today I will be giving an explanation on how to answer this question right here, where I have to show that the integral from 0 to 1, x to the power of 4 times 1 minus x to the power of 4 over 1 plus x squared dx is equal to 22 over 7 minus pi. First thing first is we have to expand the bracket right here. So it will be written like this: 1 minus x to the power of 4. It also can be written as 1 minus x squared, 1 minus x squared. It also can be written as 1 minus x, 1 minus x. Repeat the same thing, 1 minus x, 1 minus x. So you will get, when you expand, is 1 minus x plus x squared, and 1 minus x plus x squared. Then expand again. Expand again, you will get 1 minus 2x plus x squared minus 2x plus 4x squared minus 2x cubed plus x minus 2x cubed plus x to the power of 4. So simplify it, you will get x to the power of 4 minus 4x cubed plus 6x squared minus 4x plus 1. After we get the value in the bracket, so we can expand the numerator here. So it will be written like this. X to the power of 4 times x to the power of 4 minus 4x cubed plus 6x squared minus 4x plus 1. So you will get x to the power of 8 minus 4x to the power of 7 plus 6x to the power of 6 minus 4x to the power of 5 plus x to the power of 4. So after that, we will get, so now we get the new numerator. So we will just put in this term again, integral 0 to 1 x to the power of 8 minus 4x to the power of 7 plus 6x to the power of 6 minus 4x to the power of 5 plus x to the power of 4 over 1 plus x squared dx. So now we will be going to use polynomial long division on this fraction right here to expand to make it more easier. So let me just erase this real quick. So we will doing long division. So x to the power of 8 minus 4x7 plus x to the power of 6 minus 4x to the power of 5 plus x to the power of 4. You will divide it by 1. You will divide it with 1 plus x squared. So first thing first is you have to divide x to the power of 8 with x squared right here. So you will get x to the power of 6. Then multiply with this term. So you will get x to the power of 8 plus x to the power of 6. Subtract this term right here. So you will get 0. And this you will get 5x to the power of 6 plus this you will just bring it down, minus 4x to the power of 7 minus 4x to the power of 5 plus x to the power of 4. So now the highest degree right now is to the power of 7. So you have to divide it with x squared again. Then you will get negative 4x to the power of 5. So multiply it again, you will get negative 4x to the power of 7 plus and minus, you will get minus. So minus 4x to the power of 5. Subtract it again. So this can be cancelled out. So it will be left with 5x to the power of 6 plus x to the power of 4. So x to the power of 6 will divide it again with x squared. So you will get plus 5x to the power of 4. So multiply again, you will get 5x to the power of 6 plus 5x to the power of 4. Subtract it again. So you get 0. And you will get negative 4x to the power of 4. So divide it again with x squared. So you will get negative 4x squared. So multiply, you will get negative 4x squared. 4x to the power of 4 minus 4x squared. So subtract it again. You will be cancelled out. So this will be positive 4x squared. Then you will divide it again with x squared. So you will get plus 4. So 4 multiplied by x squared plus 1, you will get 4x squared plus 4. So subtract it, you will be cancelled out. So you will get negative 4. You will have to divide it with 1 plus x squared. So now we will put this value, this result we got, into our integral. So 0, 1, x to the power of 6 minus 4x to the power of 5 plus 5x to the power of 4 minus 4x squared plus 4 minus 4, 1 plus x squared dx. So as we can see here, it's quite easy to integrate right now. So next you can integrate this term here. So you will get x to the power of 7 over 7 minus 4 over 6 x to the power of 6. So this can be simplified as 2 over 3 plus 5 over 5 x to the power of 5. This will be 1. So this 4 over 3 x to the power of 3 plus 4x minus 4 tan inverse x. Then you can substitute this value here in this term. So you will get 1 to the power of 7 over 7 minus 2 over 3, 1 to the power of 6 plus 1 to the power of 5 minus 4 over 3, 1 cube plus 4 multiplied by 1 minus 4 pi over 4 minus 0. So how can we get pi over 4? You can refer to this unit circle angle, where if we use calculator, we will get tan inverse 1 is 45 degrees. So we will get pi over 4. So this 4 can be cancelled out. So you will get 1 over 7 minus 2 over 3 plus 1 minus 4 over 3 plus 4 minus pi. So simplify it again, and then you will get 1 over 7 minus 6 over 3. This can be simplified as 2. Then plus 5 minus pi. So you will get 1 over 7 plus 3 minus pi. This 3 is over 1, so you can just multiply by 7 over 7. So you will get 1 over 7 plus 21 over 7 minus pi. Then simplify it again, you will get 22 over 7 minus pi. So that's the answer. So it is proven that integral 0 to 1 x to the power of 4, 1 minus x to the power of 4 over 1 plus x squared dx indeed equal to 22 over 7 minus Bye. Thank you for listening.